Assalamualaikum warahmatullahi wabarakatuh and a very good day to the Honourable Judges, Conference Committee, fellow researchers and participants. My name is Wan Nordini Hasnor binti Wan Ismail from Faculty of Pharmacy. I am pleased to present our study entitled Preliminary Observation of Fungal Contamination in Peanut Tempeh Fermentation, Challenges in Small-Scale Production. This study begins with a simple but important question. Can peanuts be successfully developed into a safe and acceptable alternative to conventional soybean tempeh? During our preliminary production, however, unexpected fungal contamination occurred. Instead of treating the unsuccessful batch merely as a failure, we examine it as a valuable learning opportunity to identify critical challenges in small-scale peanut tempeh fermentation. In this presentation, I will share our observations, the possible factors contributing to the contamination, and the practical lessons that can help improve future production. Peanut tempeh is a promising non-soy protein innovation, but adapting a traditional soybean process is not simply a matter of changing the raw material. In our small-scale trial, the fermentation failed. Instead of hiding that failure, we treated it as data. Today, I will show how three simple signals, appearance, temperature, and pH, reveal the weak points in the process and how those observations can guide a safer, more reliable design for community-scale peanut tempeh. Why peanuts? They are locally available, nutritionally valuable, and they can diversify non-soy fermented foods. But peanuts also contain more lipid and have different physical properties from soybeans. These differences can change water retention, oxygen diffusion, heat transfer, and microbial competition. The key innovation gap is therefore process adaptation. Our question was practical. Under small scale conditions, what observable factors may contribute to early contamination and fermentation failure? The protocol was simple and realistic for a teaching or community lab. Peanuts were steamed for about 40 minutes, peel, drain, and cool below 35 degrees Celsius. We added commercial rhizopus starter at 0.3% by weight, packed the substrate in perforated bags at 1.7 centimeters thickness, and fermented it at ambient temperature. 9 replicates were monitored every 24 hours for visible mycelial growth, contamination, temperature, and pH. This slide shows the study design infographic that has been discussed earlier. The visual sequence provides the first warning signal. On day 1, there was minimal mycelial development. The kernels remained loose and surface wetness was visible. By day 2, grayish growth appeared. Colonization was uneven and condensation increased inside the package. On day 3, grey-black overgrowth and green-yellow fungal patches were present. Most importantly, the peanuts never formed the compact white cake expected when rhizopus successfully dominates the substrate. Temperature was the second signal. The mean rose from 26.18 degrees on day 0 to 31.01 on day 1, suggesting that microbial metabolism had begun. It then fell to 29.29 on day 2, indicating disruption of sustained starter activity. On day 3, it rose again to 31.22 degrees. Because that final rise coincided with obvious colored contamination, it is more consistent with mixed microbial activity than with healthy, controlled tempeh fermentation. The value lies in the pattern, not merely the peak temperature. The third signal was pH. It increased from 5.46 at day 0 to 6.62 at day 3, a rise of 1.16 units. This alkaline shift is not the desired signature of a stable fermentation. Together with the visual contamination and irregular temperature profile, it supports the interpretation that unwanted microorganisms and protein degradation were contributing to the batch deterioration. We should be careful. pH alone cannot identify the contaminant, but it is a useful low-cost warning indicator. Bringing the three signals together suggests a multi-factor process failure. First, excess retained moisture and condensation may have created favorable conditions for competing organisms. Second, the peanuts were not packed firmly. The gaps between kernels limited the ability of rhizopus hyphae to bridge the substrate into a continuous cake. Third, uneven aeration may have produced local areas that were too wet or too exposed. These are plausible interacting contributors, not confirmed causes, so the next stage must test them under controlled conditions. The innovation response is practical and low cost. First, dry the cooked peanuts thoroughly to minimize free surface moisture. Second, pack them more uniformly so adjacent kernels can be connected by the developing mycelium while maintaining a consistent thickness. Third, standardize the distribution of perforations to balance oxygen exchange with condensation control. Fourth, use temperature and pH as simple early warning tools. The lesson is that innovation is not just replacing soybean with peanut. It is redesigning the process around the new substrate. The next research phase should convert these observations into measurable operating limits. We need control factorial experiments on moisture, packing density, and perforation pattern. We should also identify the contaminating microorganisms and include clear quality and safety endpoints. Once verified, the protocol can be translated into a simple decision guide for student laboratories, community producers, and small food entrepreneurs. The target is not merely a successful batch, but a repeatable, safe, and teachable peanut tempeh process. To conclude, our peanut tempeh fermentation was unsuccessful under the tested small-scale conditions. But the failure produced a useful process map. Visual changes showed the loss of rhizopus dominance. Temperature and pH provided supporting evidence of instability. Together, the observations point to moisture, packing density, and aeration as priority variables for optimization. A failed batch is therefore not the end of innovation. When it is documented when it is documented systematically, it becomes the first step toward a safer and more reliable product. Thank you.